another screencast, Angles and Polygons. It's like Angles and Polygons number 2. It's the exterior angles of any polygon we're going to work out today. So you need to have watched the interior angles one first, as this will be very, very difficult for you if you haven't watched that. If you've watched that and you got it, it's going to be a piece of cake, which is fantastic. And we all like cake, don't we? Especially chocolate cake. If you ever want to bake Mr. Warren a cake, bake him a chocolate cake. So we should know this information already, but I will whip through it again. A polygon is any two-dimensional shape formed with straight lines. Triangles, quadrilaterals, pentagons, and hexagons are all examples of polygons. The name tells you how many sides the shape has. For example, a triangle has 3 sides, a quadrilateral has 4 sides. Here's some examples. Yip-de-doo-dah. All right, so we should be able to name them. We've got a triangle, hopefully a quadrilateral, a pentagon, a hexagon, a heptagon, and an octagon. All right. So remember that we have a shape, the sum of the interior angles. Now, funnily enough, we need to know the interior angle to help us work out the exterior angle. So the sum of the interior angles is the number of sides, take away 2, times by 180. If you've watched the other video, you'll understand why, but we can create triangles from that. So I won't keep you any longer. But the sum of the exterior angle of any polygon is actually 360 degrees, and we're going to explain why in a second. So here is the reason why. The sum of the exterior angles of any polygon is 360 degrees. All right. The interior plus exterior angles always equal 180 degrees. That is a really key piece of information. So we're going to demonstrate this now. So definitely you need to make notes on this. Can you see that line that goes out? That line creates what we call the interior angle and the exterior angle. These two angles together will give us the 180 degrees. This is the exterior angle. All of these exterior angles added together will give us 360 degrees. So we will continue to click on to show you. There we go. We can see that's clearly 180 degrees, can't we? So if the interior angle is 120, what's the exterior angle going to be for the shape? Hopefully you're saying to me, Mr. Warren, it's going to be 60 degrees, and you would be correct. If you said anything else, you're wrong. I'm sure you haven't. Next one up, right? Same thing. We've got 120, so outside's going to be 60. And the same thing goes on for all of these sides and shapes. Yeah. Now, the great thing is, and there is a little video online that shows you why, but if we condensed all the exterior angles down, we would find that it creates 360 degrees around the outside. But we can't do that here because of technology, as PowerPoint does not give me that power. So if we added up all of those, so we've got 60 here, 60 here, 60 here, 60 here, 60 here, 60 here. If we added them all together, we would end up getting 360 degrees. So that's really, really useful when we're answering questions. Those two pieces of information that creates a straight line, the interior plus the exterior angle equal 180 degrees, and all of these exterior angles added together give us 360. I won't keep you any longer. Let's look at a couple of questions here. All right, so what I would like you to do is I would like you to try and do these without any help from me. All right? Now, funnily enough, I'm using very similar shapes to the ones we used in other questions. So you might want to go back and look at your books. But anyway, give it a workout. Try and work out X for a start, then Z and Y. If you could do that now, that'd be fantastic. And then we'll go over the answers. Okay, so here we go. First things first, let's work out what all the interior angles of this shape will be. We've got 1 side, 2 sides, 3 sides, 4 sides. So straight away, it would be 4 minus 2 timesing by 180. So that would be 2 timesing by 180. So we should know that all the interior angles equal 360 degrees. I'm sure you did anyway. The next step would be to add 98, 92, and 85 together. And if we do that, believe it or not, we have 275 degrees. So that means that this angle plus 275 plus x, or x plus 275, is going to equal that 360. So what we do, we'd take away 275 from both sides, and we'd end up with x equaling 85 degrees. So we can say that x is 85 degrees. Now, these shapes are not drawn to scale. Can I just say that now? Blatantly not drawn to scale. But anyway, we won't worry about that. So what would we do to work out what z was? So we've got 85 here. We know this adds up to 180 because we've got straight lines. So we've got 85 plus z equals 180. All right, I can write that down. So I've got z plus 85 equals 180. Take 85 away from both sides, and we end up with it equaling 95 degrees. All right. Now, funnily enough, I've got 85 over here, although that is absolutely not an 85 degree angle. So my y would also be 95 degrees. Okay. So there we go. That was easy, I hope, although I might have thrown you over my very dodgy drawing. Next up, I would like you to work out this bad boy. Exactly the same process, just change the numbers and see how you've gone. Okay, so here we go. First things first. The formula for the interior angles is as such. So how many sides did this shape have? It had 1, 2, 3, 4, 5, 6, 7. So we 7 take away 2, timesing by 180, that would be 5, timesing by 180. 5 times by 180 is 900. All right, so now all of these interior angles will equal 900. So I'm going to do that now. I'm not going to write them all out. Hopefully you will. So I'm going to go 120 plus 130 plus 120 plus 135 plus 130 plus 110, and all of those angles together gets me to 745. So I know that y plus 745 equals 900. Take away 745 from both sides, and then y is going to equal 155 degrees. So that's y, 155. So if y is 155, what is z? So we've got that line, it's 180 minus away 155, and we end up with 25 degrees. So z equals 25. Hopefully you've done that really well. Now, as I said, if you haven't watched the previous video on internal angles, you probably did struggle. So go back and watch that, make the notes on it. If you have, I think you've found that relatively easy because we're actually only adding in that one piece of information. So with that knowledge, it's time for you to do the quiz. Please go and do the quiz now. All you got to do is find out the value of y and z for all of those questions, okay? Is there x in there as well? Oh, yes, there's x in there. So x, y, and z, find out those values. Come back and see if you got it right. A little bit of a helping hand here. All right, this is, it should have one there. This is what type of triangle, which means that all the sides are going to be the same. This is what we call a regular, so it means that all of these angles will be the same. And then you've got your other ones, all right? So nice and easy, lemon squeezy. Give it a go. Come back and see if you've got it correct. Here we go. Here goes the answers now. Okay, so hopefully you've done really well there, but that's not where the quiz finishes. It's a double whammy today. And it's really simple, this part of the quiz. All you have to do is name the shapes. All you got to do is name the shapes, yeah? Can you name the shapes? If you can, well done. If you can't, you need to learn them. So pause the video, name the shapes, come back and see if you're correct. Well done. Hopefully you've done that now. Let's go. Let's look at our answers. Over the page, we've got triangle, quadrilateral, pentagon, heptagon, hexagon, and octagon. Write a little revision card on that if you possibly can. You can't catch me. I'm the gingerbread man. And then before you know it, you'll be amazing at maths. As always, it has been a real privilege, more than a pleasure today, a real privilege to help you with your maths. Keep it up. Until next time, see ya.